I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover threat modeling, threat candidate triage. Here's the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training and that you've completed the requirements taxonomy, security requirements, secure design principles, apply secure design, and threat prioritization plan training. Additionally, you should have completed the threat modeling overview, model creation, and model analysis trainings. This training will cover threat candidate triage. Before getting into threat candidate triage, let's review where it fits in the overall threat modeling process. Here's the threat modeling process with its three individual activities: model creation, model analysis, and threat candidate triage. Let's consider the triage activity. In the threat candidate triage activity, the threat modeling SME and the development SME take the list of threat candidates and review each to determine which is valid. The result is the creation of a set of triage threat candidates. These are sent along to the threat ranking activity within the threat prioritization process. Once again, returning to the NIST threat modeling lifecycle, we see that the threat candidate triage activity corresponds to the identification activity in this lifecycle. Now, some might argue that because we're evaluating the candidates, this must mean that we're doing investigation. That's an interesting argument. However, we're not putting it through the formal threat prioritization process here. This is a true triage where we're just eliminating those issues which are obviously not valid. Now let's work our way through the same example used in previous threat model trainings to illustrate how the threat candidate triage is undertaken. Recall that our example system is comprised of a core service, a web server, and a console interface. These are connected to a web browser and a terminal, and eventually to an administrator who's interfacing with both. Also recall that in the analysis of the threat model, it was recognized that the audit log, now shown here, was left out. So this is the most up-to-date diagram of our system. Let's look at what we did with it next. In the threat modeling activity, the system was taken and a series of DFDs were created from it. This is the highest level one. Recall that during the analysis activity, it was determined that the audit log had been left out. Here we see it in place. This is our most up-to-date DFD of the example system. Now let's review the analysis process applied to this model and the resultant issues generated from it. In the discussion of threat model analysis, it was brought up that one should focus on those areas where you have differentials in trust. In that training, the normal operation flow, which we see here, was selected to illustrate the analysis methodology. Within the normal operation flow, there are three processes of interest. These are the core service, which is a fully trusted entity, the web server, a third-party entity, and therefore at a lower level of trust, and finally, the web browser, a process external to the system and therefore untrusted. Note that we have two boundaries here: the core service boundary between the core service and the web server, and the machine boundary between the web server and the web browser. These four data flows were then analyzed. The analysis of these four data flows yielded 10 issues. These were violations of three cybersecurity requirements. These identified issues are technically referred to as threat candidates. Now let's consider how we're going to triage the results of the analysis. The methodology we're going to employ to do the triage is straightforward. We'll take each of the issues, those threat candidates identified in the analysis activity, and review each to determine whether it's valid. This determination is the goal of the triage activity. Once a determination has been made for a given threat candidate, then for valid cases, we may assign a preliminary severity. And if it's not valid, we'll provide a justification as to why the issue is not valid. Additionally, we can provide notes for those who'll be working with the information later. Now let's look in detail at the values for the determination and severity fields. The first step in deciding whether an issue needs to be dealt with or not is to make a determination regarding the threat candidate's validity. There are three different determinations that we can assign. The first is that the issue is valid. The analysis properly identified that there is a violation of a cybersecurity requirement. If this is the case, we'll assign a preliminary severity if appropriate. The next case is that we determined there to be an insufficiency in the model itself. The analysis would not have yielded this issue had the model been correctly formed. The model will need to be updated, and the analysis will need to be performed again. Finally, we have non-issues. These differ from valid and insufficient model ones because the issue itself, as stated, is valid. The element model is correct and complete. However, it does not sufficiently capture the totality of the system. This is an abstraction level limitation. Something else within the system renders this issue non-impactful. Keep in mind that if the vast majority of threat candidates are being determined to be invalid, then there's a problem in the execution of the analysis, the triage process, and possibly the model creation activity. And so a cybersecurity SME should be very wary when a high number of either insufficient or non-issues show up during the triage process. For issues that have been determined to be valid, a preliminary severity may be assigned. Keep in mind that this is an optional step. It should only be done in cases where there's an issue of importance. If we're dealing with a run-of-the-mill issue that can go through the threat prioritization process without having to be pushed to the front of the queue because it's blatant that this needs to be corrected, then assignment of a preliminary severity may be skipped. Note that the template provided for the threat modeling threat candidate triage does not include a particular list of values that should be used for the preliminary severity. The reason for this is easy to illustrate if we consider the following. Here's the CVSS score. It has values ranging from 0 to 10. Alternately, we can look at the CVSS rating. Its values are low, medium, high, and critical. We've added a true 0 or none here because that makes it easier when dealing with automation. These aren't the only choices for severity, also known as rank. If we look at what's specified in ISO SAE 21434, for example, we have very low, low, medium, and high. Unlike the CVSS ratings, the ISO SAE 21434 doesn't specify what the values should be aligned to. The AVCDL chooses to align them to the CVSS rating range. Your organization might use something completely different. You might have a 3-value severity, low, medium, and high, or simply a bug bar, bad and not bad. These are very organizationally dependent things. And so this is provided only as examples of what may be used. And don't presume that this information is going to be consistent from organization to organization. Now let's go through the exercise of doing triage. And we'll start with the identified issues, the threat candidates. We'll bring in the corresponding DFD. For reference, we'll also bring in the text of the cybersecurity requirements that are at play here. And now let's look at the issues one at a time and talk about the triage determination that we'll make for each of them. For the first one, we're dealing with ESD9, the data flow that goes between the web server and the core service. The requirement we're violating is that we don't have data integrity. And in fact, there is no integrity check stated in the model metadata. This is a non-issue, however, because the IPC protocol used provides integrity guarantees. And so that takes this issue out of consideration. The second issue is on the same data flow. What we're saying here is that we have unauthenticated endpoints, specifically the web server. We know that the web server is authenticated because it's the trusted part of the element. As you can see in the notes, for ESP03, which is the web server, authentication is unspecified and assumed no. Our determination, upon consultation with the development SME, is that this is a model insufficiency issue. We know that the web server is authenticated. Now, it's not necessary to go into how it's authenticated or why it's authenticated. This is a threat candidate triage activity. The actual implementation is not the focus here. Suffice it to say that this is not an issue because we have a model insufficiency. For the third issue, we're dealing with data flow ESD10, which is from the core service to the web server. The requirement that's violated here is one of data integrity, and it's the same issue that we had with the first issue. Since we have data integrity guarantees within the context of using the IPC protocol, it's a non-issue. Issue 4 rounds out the issues between the core service and web server. This one again is data flow ESD10 from the core service to the web server, and it's the same issue that we had for issue 2. We don't have authentication on both ends. We've already established that the web server is authenticated, and so, like issue 2, this is a matter of an insufficient model. For the next 6 issues, we're going to consider them collectively. The reason is that they stem from the same fundamental problem. For issues 5 and 8, we have that data going between the web server and web browser is not encrypted. For issues 6 and 9, we have that there's no integrity check between the web server and web browser. Finally, issues 7 and 10, we have that the endpoints aren't authenticated. The web browser is an external, unauthenticated entity. The underlying problem leading to all 6 of these issues is that we're using the HTTP protocol. Now, we put in the notes our recommendation to use the HTTPS protocol. This doesn't mean that there isn't some other mitigation that could be used, but using HTTP protocols without any security whatsoever can easily be remedied by adopting HTTPS protocols. We could have assigned a preliminary severity to this last set of 6 because they're taken together and they would have the same level of severity. But there's no real motivation to do so, given the fact that the only issue is that the communication protocol that's been chosen is inappropriate for what we want to accomplish in a cybersecurity context. And so we'll let the threat prioritization process handle the actual assigning of the severity or rank. That covers the basics of doing the threat modeling threat candidate triage. Now let's review some of the important points that we've covered in this training. Address the invalid issues first. Handling these is typically straightforward, as the development SME is probably going to be able to provide immediate rationale as to why things aren't valid. Next, cluster like issues, because, generally speaking, the like issues are going to have similar treatments. This is not always going to be the case, but in many cases it will. As we saw with the issues between the web server and web browser, they all stemmed from the same fundamental problem. If you make a recommendation, do so based on best practices. And remember that this is just guidance. Within the threat prioritization process, the mitigation determined might be accomplished using completely different treatments. Finally, if it's appropriate, assign a preliminary severity to the issue. Again, this is highly organizationally specific, and it's going to be influenced by a number of factors, including the regulatory environment, where the issues are coming from, and who's going to be processing them. Also, we know that once the issue goes into the threat prioritization process, then it'll be much more formally addressed. The materials that were used to cover this example are in the location shown here. It's important to note that this includes the DFDs, as well as the threat model, model creation, issue tracking, and triage workbooks. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it, if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. This training is the last in the threat modeling sequence. If you've completed all the trainings related to threat modeling, you can proceed to one of the other trainings at this level. These include attack surface analysis, penetration testing, and vulnerability identification. Additionally, if you've completed secure coding and its prerequisites, you can also proceed to static analysis, dynamic analysis, fuzz testing, and secure code review. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL Git repository.